Hello, Blackhawks. Hope everyone is doing well out there. Welcome to our first online lesson. Now, we're going to try to keep things as normal as possible. Um, Basically, meaning that we'll kind of go through the notes the same way as we did in class. You're welcome to print out a hard copy. I have located in Canvas. Or if you don't want to print out a hard copy, you can just write it in a notebook. Whatever you feel like you need to do, or whatever is going to be best for you to learn. Um, so basically, the idea right now is we're going to look to have about one section of notes per week. Uh, Earlier in the week is when we'll have our notes listed. Now, this first week will be a little different. I'm going to have it posted by Wednesday, which you'll notice, and I'll send an email out. But anyways, we'll go ahead and just get started. So today's title for this section is going to be 9.1, titled Trig Functions and Right Angles. So the question is, how can I use trig ratios to find side lengths and angles of triangles? All right, so let's go over some of the definitions. Now, good news is I think this is a good lesson to start this quarter with, especially kind of trying something new, um, through this online route. But the good news is you guys have seen this before back in geometry. Maybe just need a little refresher on it. If you remember the phrase SOHCAHTOA, then you'll probably know exactly what we're talking about. So first off, trigonometry is the study of relationships among the angles and sides of a right triangle. A trig ratio compares the side lengths of a right triangle. So as you guys might remember from SOHCAHTOA, you'll have like opposite over hypotenuse, things like that. That's what it means by comparing the side lengths. A trig function has a rule given by a trig ratio, and we'll see that here very shortly. So this symbol right here is a Greek letter theta, is very commonly used in math as an angle measure. As you can see in the triangle over on the right side here, you're going to basically have one angle that's going to be your reference angle, and that'll be labeled as theta. So then you can see the other parts of that triangle. Like right here, we have the hypotenuse, which is going to be the longest side of the right triangle. So you can kind of see here, that's our longest side across from the right angle. You have this side here is the opposite, which is going to be across from that angle. You kind of see how the angle formed. You have the opposite side is going to be that segment formed. And then you have your adjacent side, which is going to be the side closest to your angle that's not the hypotenuse, right? So you see how the angle shares those two sides. So it's going to be the non-hypotenuse angle. So let's look at some of our trig ratios. And I'm going to write off to the side here uh, the sort of the shortcut rule that you might remember from geometry, and that's SOHCAHTOA. Really, all that is a shortcut to remember what the ratios are for each of your main three trig functions. So sine is the one with S, cosine is the one with C, tangent is the one with the T. So when we write out our actual rules here, let's go ahead and we'll write out like opposite, or I'm going to do like OPP over hypotenuse. Okay. Cosine over here says is adjacent over hypotenuse on the left. Right. So I'm going to put ADJ over HYP just for short. Tangent is then going to be opposite over adjacent, right? The O over A, so opposite over adjacent. And those are your three that you recall from, or hopefully remembered from geometry. Now, in Algebra 2, we're going to introduce three new ones. Really, they're super simple because all they are the reciprocals of your original three. So this one right here for sine is going to change to hypotenuse over opposite. In other words, you just flip the original function. So sine pairs with cosecant. Now cosine is going to pair with secant. So you flip that, and it's just going to be hypotenuse over adjacent. Okay, and your last one, tangent and cotangent, those are easy to remember. They pair together because they both have tangent in it. So that's going to be adjacent over opposite. Okay, so those are your 6 main trig functions that we're going to use throughout the course of this lesson. Let's go and do a quick example using the right triangle that's already provided here for us. And we want to make sure we're using the angle that has, or the angle that where theta is located, because that's going to make the whole difference in terms of which side is opposite, adjacent, and the hypotenuse actually stays the same, but opposite and adjacent will be the ones that change. So let's start off with sine. Okay, so sine is going to be opposite over hypotenuse. So we look at what's across from that angle, right? That's opposite, and that would be our 4. Now, if you need to, you can put like an O here or like an OPP to just write out all the corresponding side lengths so you can use those for every part. So that's your opposite. Okay, the 3 right here on the bottom, that's going to be your adjacent side. So I guess I'll just do A. And then the hypotenuse is going to be the longest side, which is your 5. So that'll be an H, right? Now, let's go ahead and set up our ratio. So sine is O over H, or opposite over hypotenuse. So we have 4 is the opposite side. 4 is the opposite side over the hypotenuse, which is 5. Cosine now is going to be adjacent over hypotenuse, or A over H, which is going to be 3 is the adjacent over the hypotenuse, which is 5. And then tangent is going to be opposite over adjacent, so O over A. So O over A would be 4 over 3. Now, once you have those 3, usually the shortcut is I just flip the original 3 functions, right? So this one will be 5 over 4. This one will be 5 over 3. This one will be 3 over 4, right? Super simple. Really, the only complicated part there is just remembering which ones pair together. It just takes practice, but that's essentially it. All right, so let's go ahead and do an example where we have to evaluate our 6 trig functions for an angle theta. Now, what's going to happen on this problem is going to give you a 3 side lengths. Okay? You have your opposite, you have your adjacent, and you have your hypotenuse. Now, you don't have to do this, but I think it's definitely going to help. Let's just draw a right triangle. And keep in mind, all these sine, cosine, tangents, everything that we're working with here, all are when you deal with right triangles. Okay, so the opposite side is going to be 8. The adjacent side is 15. And the hypotenuse is going to be 17. Now you can label these if you want. I'm just going to leave them without the A, B, and C on there. As long as you understand which side's opposite, adjacent, hypotenuse, that's all that really matters. All right, so let's go ahead and just set these up real quick. So sine, and the way I'm going to write this is sine theta equals, now we have our opposite side, which is the 8, over the hypotenuse side, which is the 17, or like we just talked about in the last problem, if you want to, you could just put an O here for the opposite, an A here for adjacent, and an H, and we'll use that for every single problem. Okay, so cosine theta is now going to be the adjacent side of 15 over the hypotenuse side of 17. And then tangent is going to be opposite over adjacent, so 8 over 15. And those are your 3 main ones again. And once again we said all you really need to do now is just flip the original 3. So remember, sine and cosecant pair together. So that'd be 17 over 8. Secant theta would be 17 over 15. And cotangent theta is going to be 15 over 8. Okay? So just like we would normally in class now, if you look at the next part, it says we have a guided practice example. And I guess since this one does have, it says find the values of the 6 trig functions for angle B, I guess we should go ahead and label these angles, right? So this is going to be, let's see, this is going to be B, this is A, that's the angle that we were using. Okay, that's where theta was, and I guess this would be C. So now what you're going to do is you're going to basically try to figure out what is your opposite and adjacent from that angle. So I'll give you guys a moment to go ahead and, if you want to pause the video, go ahead and try it on your own. Okay, so hopefully you had a chance to try it out. So let me just go ahead and draw this right triangle one more time. So here's angle B. This is the angle we're going to reference now. So this 15, instead of the adjacent, notice how it's across from the angle, right? So that was actually going to be our opposite side this time. The 8 here would be your adjacent, and then the 17 is going to be your hypotenuse. So notice how the hypotenuse stayed the same for both of those problems, right? So the hypotenuse will never change. It's really the opposite and the adjacent side are the ones that'll change. So let's go ahead and check your work. So we have sine of theta, or sine of b. Let's go and put a b here just because that's what it asked for in the problem. So sine of b is going to be O over h, so 15 over 17. Cosine of b is going to be, the adjacent side now is 8, 8 over 17. And your tangent b is 15 over 8. Okay, so let me go and write these answers out real quick. Whoops, sorry, my pen's not. There we go. Okay, so we got cosecant b is 17 over 15. Uh-oh. Sorry, guys. My pen's acting up right now. There we go. 17 over 15. Secant is going to be 17 over 8. And cotangent of b is 8 over 15. All right, so those are your 6 trig functions just by being given those side lengths. Okay, so these 3 functions that we introduced today, cosecant, secant, and cotangent, can also be referred to as reciprocal functions. And essentially what those are is, for cosecant, it's going to be sort of the reciprocal of sine. So we can also write that as 1 over sine. Secant theta is the reciprocal of cosine. So we can write that as 1 over cosine theta. And cotangent is basically going to be 1 over tangent, right? We know that's the reciprocal. That's the reciprocal of tangent. All right, so those are just another way you can represent those 3 ratios. All right, so now what we're going to try is we're going to find the exact values of the 5 remaining trig functions for b. So what's going to happen here is going to give you one of your trig ratios. So we have sine given. Well, sine we know from before is opposite over hypotenuse. Okay, so that means for this problem, your opposite side is a 5 and your hypotenuse is an 8. Well, that just means we know 2 sides of the right triangle. So let's go and draw our right triangle again. Okay, and I'm just going to label this B just to kind of keep things consistent here. So the opposite side would be over here. So this side length is going to be a 5. And your longest side here is your hypotenuse, which would be an 8. So as you guys probably recall, you have 2 sides of a right triangle. You're trying to find the missing side. What do we need to do here? I'm sure you guys guessed it. That's the Pythagorean theorem. Okay, so that's the theorem we're going to use here because that'll easily get us our missing side length. Now, make sure when you set this up, so remember the rule is a squared plus b squared equals c squared. Make sure your 2 legs, right, these 2 right here, those are your legs, are going to be your a and your b. It doesn't matter which order you put those in. So we'll have 5 squared plus x squared equals 8 squared. Okay, and then let's go ahead and simplify this down real quick. So it'll be 25 plus x squared equals 64. We got to solve for x now. So we're going to subtract 25 to both sides. And now we'll have x squared equals, what would that be, 39. All right. And then from there, we're going to square root each side. And if your square root comes out evenly, we can go ahead and simplify that down. However, square root of 39 won't break down any further, right? We could try if we wanted to, doing our little brackets. Oops. Sorry, these pens are acting up a little bit on me today, obviously. Oh, probably because I'm off the page. The square root of 39, we could break down to a 3 and a 13. However, those don't break down any further. So we'll leave it as square root of 39 as our answer. And notice how it says find the exact values. So we don't want to round it, right? So then our last piece, if you want, you can go ahead and change this. The x where it originally was now is going to be a square root of 39. Okay. And we'll just set up our ratios real quick. So sine is 5 over 8 as given in the problem. I'm just going to write them out again. Cosine now is going to be your adjacent is square root of 39 over 8. Tangent is going to be opposite, let's see, whoops, is going to be 5 over square root 39. Okay. And then the rest of those, I'm going to let you guys just go ahead and flip those. But basically, those would be your other three. I'm just running out of space on my page. But that's essentially how you would find those missing sides, because or find those three trig functions, because we were missing a side. So we had to do a little bit of work first. Okay. All right. So we're going to move on then. Now, in this box here, there are special right triangles. Those are 30, 60, 90 triangles and 45, 45, 90 triangles. We're actually going to come back to this in a later lesson. Technically, these are shortcuts you can use to find missing sides, but just for the time being, I want to make sure we can practice setting up trig functions just to solve them without really remembering either a shortcut or anything. I mean, if you can follow what's in this box, by all means, you can do it this way. But I want to make sure we remember how to write our actual equations with the trig function and solve for what's missing. Okay, so here we have a special right triangle. It's our 30, 60, 90 triangle. The reason we know that is because this angle is 30. This is your right angle is 90. We know all angles have to add up to 180, right? So then that would be a 60-degree angle. So if you want to try to refresh on this special right triangle, go right ahead. But I'm going to go ahead and just set up a trig ratio for this problem. So there's already a step written on here. Now, notice our goal is we're going to find this missing side, which is x. Now, unlike the last problem where we had two sides given, now I only have one side given, right here, one angle given, and a missing side. So we can't use the Pythagorean theorem for this one. Instead, we're going to use a trig ratio. More specifically, we're going to use the ratio that contains this side, which is your adjacent side compared to 30 degrees, and this side, which is your hypotenuse. Notice we have an A and an H. So thinking back to your trig ratios that contain A and an H, yeah, we would want to use the cosine function this time, right? Because that has the adjacent and hypotenuse. So as you go to set this up, you're going to do cosine, you're going to do cosine of 30 equals, and then you type this in, or sorry, don't type that in yet. We'll get to that in one sec. So then you're going to do your x is your adjacent side over 8, which is your hypotenuse. So notice this is the ratio for cosine, right? Just like we did before, except now we're writing it with variables because it has a missing side. We don't have all the sides given. Okay, and notice how I also put the angle here, right? Before we just put theta or a variable, but now we're actually going to put the angle inside of it. All right, So ultimately, your goal now is to solve for x. And when you do that, you basically want to isolate the x. And we know for dividing by 8, the way to undo that is we just got to multiply 8 to each side. Okay, and those will essentially cancel out. All right, so your goal now is to basically solve for x. Or sorry, we've already solved for x. Now your goal is to actually find the value of x. We're just going to type that into our calculator. So if you have your own personal calculator, especially the TI Inspires or TI 83s or 84s, you're going to want to make sure you have it in the right mode because there's a radians mode and a degree mode. So we want to make sure this is in degrees, right? Because that's what's given in the triangle. All right. And then, sorry, I'm typing this into my calculator right now. And that's going to give us 6.928. Okay, and that is the value of our missing side. So we'll say for now, let's do 2 or 3 decimal places. I'm going to do 3, just to kind of keep things consistent. You know, if you put 2, that's fine. I can't remember how we have your homework set up right now, but either way, as long as you understand, this is going to be 6.928 as the missing side length. Okay. All right, I'd like you guys to go ahead and take a second, pause the video, and go ahead and try these 2 guided practice problems, and I'll write out my answers here momentarily. All right, hopefully you had a chance to test it out. Let's go ahead and see what we got here. So here's 60. So 60 is your angle you're referencing. Now, notice the side that's next to it is what's missing. That's x, which is also your adjacent side. And then over here, you have your longest side. Oops. All right, sorry guys. I'm just getting familiar with this. I think we're recording. Okay, so that's your hypotenuse side. So A and H, once again, there's your cosine function. Cosine of the angle equals x over 14. All right, so once again, kind of set it up the same format as you did before. Now we have to solve for x. So times 14 to each side. Okay. Type in that into your calculator, and so you do 14 times cosine of 60, and that answer is going to give you 7. So it's actually an exact answer, which is nice, and this is because it's another special type of triangle. It's a 30, 60, 90 triangle. That would be a 7. All right. Now, by the way, the reason why this one didn't come out perfectly, even though it was the same type of triangle, is because the shortcut method, see how this would be the square root, x square root of 3? So obviously it's going to be a different number than what, or it's going to be a decimal instead of a whole number. All right, and then let's go ahead and work this one out again. Like I said, hopefully you already had a chance to try it. So this time we have our opposite side, right? This across from the angle. And we have this side, which is the hypotenuse. It's across from the right angle. That would be your sine function. Okay, so we got sine of 45 equals, and then we have 10 over x. 10 over x, right? Because it'd be opposite over hypotenuse, 10 over x. So now the trick with this one, however, is if I'm trying to solve for x, notice how x is in your denominator this time. Okay, so instead of timesing 10 to each side, we actually want to get that out of your denominator by multiplying x to both sides. Okay, so it'll look something like this. So the x's will cross out. So then you'll have x times sine of 45 equals 10, right? Just doing some algebra here. Well, if I have this on the left side, the only way to get rid of it to solve for x is if we get rid of the sine 45. So let's divide sine 45 to each side of your equation. All right, so that will cross out. That will cross out. And now we could just type that into our calculator, and that should basically give us our answer. So we got 10 divided by sine 45, and that'll be approximately 14.142. Okay. All right, so let's go ahead and move on to a couple or one more problem. This is going to be kind of a real world example and sort of see just kind of how we can apply this for this problem. So it says to calculate the height of a building, Joel walked 200 feet from the base of the building and used an inclinometer, I think is how you pronounce it, to measure the angle from his eye to the top of the building. If his eye level is at 6 feet, how tall is the building? All right, so you can clearly see the right triangle here, and I'm going to go ahead and label this right here. That's where our right angle is going to be. Now, the side lengths that you're looking for and what's given right next to this angle is your adjacent side. And then what is the D going to be right here? What side length is that compared to 76? Well, it should be the opposite side. Okay, so now we have an A and we have an O. So the one with A and O, that would be tangent, right? So katoa. So that's tangent. We put 76 here equals, come on. Sorry, my pen's acting up again. This is, I guess, one of the downsides to technology. All right. So anyways, since it's not working at the moment, just basically type in tangent of 76, and it's going to be equal to, there we go, equal to opposite over adjacent, so O over 200 times 200 to both sides of your equation. Okay. So that will cross out, and we can find our missing side. Oops, sorry, it's not O, it should be D right here. So then we type that into our calculator, 200 times tangent of 76, and that will give us approximately 802. Oops, 802. There we go. 802. Well, you get the idea. So I'll let you guys go ahead and write this on your paper. It's going to be 802.156. Okay, so that is part one of the lesson. All right, so if you want, I'll leave it up to you guys. You can either move on to the next part right in a row, or you can practice some of the homework problems and then come back to this the rest of this lesson when you feel like you want to. All right, so there is lesson part one.